Welcome back. So let's continue our exposition of basic data types in OCaml, and we continue with the type of floating point numbers. The values of floating point numbers are always written in a way which allows to indicate the fact that you really have a floating point number and not an integer, which means you have to use either a decimal point or an exponential or even both. In the same way, the operators on floating point numbers have also to be written with a dot at the end, so you have plus dot, minus dot, and so on. You have, of course, all the usual functions on floating point numbers like square root, sinus, cosinus, ceiling, floor, and so on. So this is very important, so let me just repeat it. You have to indicate in the writing of a constant the fact that you are using floating point numbers and not integers, so you always have to use a dot or an exponent in the constants of floating point type, and you always have to use a dot in the operations working on floating point numbers. Now let's have a look at some basic floating point expressions. Here we have an addition between two floating point constants. Then we have a multiplication between two floating point constants. Again, the last two examples demonstrate that you are really not allowed to mix integers with floating points without using explicit conversion. Like for instance, trying to calculate an integer sum between an integer and a floating point number gives us a typing error. And exactly in the same way, trying to apply floating point multiplication to two integer values gives us a typing error. This is in fact an important principle in OCaml. All the basic types are disjoint, which means there is no value which belongs at the same time to one type and also to a different type. In contrast to some other programming languages, we have no implicit conversion between data types, which means that if you want to have conversion, then you have to write down the explicit conversion operator. There is of course a very good reason for this. The reason is that implicit conversion between types wouldn't go well with type inference, so this is a small price to pay to have this very important and very convenient feature of type inference in the OCaml system. In OCaml we have in fact explicit conversion operations between almost all basic data types, and if they don't exist then it's very easy to write them by yourselves. For instance, between floating point numbers and integers numbers, we have a float of int to convert from int to float, and int of float to convert from float to int. Now we have to tell you how to write down a function application. This is very easy. You just write the name of the function followed by the argument. We will come back to functions later during this week. Just let me point out that parentheses are a priori not part of the syntax of function application, so you just write usually the function name followed by the argument. You have to use parentheses only if it is necessary to indicate the structure of a more complicated expression. Our next data type are characters, written jar. This type contains 256 values of type characters, the constants of which can be written either as letters inside of quotes or using various other notations like octal numbers, decimal numbers, hex numbers, and so on, which you can find all in the manual. We have conversion functions between integers and characters in both directions. And in fact, as you might see from the names of these functions, these are coming in fact from a module called jar. This is all we have to know for the moment about using this module. In fact, we will learn much more about modules in the last week of this MOOC. Here we have some simple expressions working with characters. So for instance, we can ask for the integer code of the character capital A, which is 65. We might also use decimal code numbers to denote character constants. Like in the next example, we have here a character constant with the integer code 122, and when we ask for its conversion into integer, we get of course precisely that value, namely 122. We might also convert in the other direction, so taking an integer code and convert it into a character, as we can see on the next
example with jar.chr, and this is again our letter A in capital. And finally, the last example demonstrates that in fact the two conversion functions jar.chr and jar.code are in fact inverse to each other. So when we go in one way and then back again, we obtain precisely the same value.
Finally, we have the type of strings. As in almost all programming languages, string constants are written between double quotes. You have the operator caret used as an infix operator to denote string concatenation, and you have lots of usual functions like calculating the length of a string with strings.length. You can convert a string to an integer provided that the string really means an integer, and in the same way you can convert a string to a float provided that you have written a string which really means a float. Some of the pitfalls, so let me repeat again. The basic data types are disjoint, so you cannot rely on implicit conversion as it is the case with some other programming languages, and you always have to use explicit conversion functions. Strings, as many things in computer science and as this MOOC, are always numbered starting from 0 and not starting from 1. A final point is, if you happen to look at old documentation of the OCaml system, you may find a different module of strings which used to be modifiable, but this is no longer the case, so strings are just non-modifiable strings in OCaml.
Now some expressions about strings. Here we have the concatenation of two strings ABC and DEF, which gives us, of course, a string ABCDEF. Then we have some basic and important functions on strings, like calculating the length of a string using the function string.length, which is, of course, as expected, 5. We may try to convert a string into an integer. This is an operation which might fail if you put as argument any arbitrary string. However, if the string that you put as argument indeed indicates an integer, then this is the integer value which you obtain. However, you should not confuse the types string, which might represent an integer, with the integer value itself, which is of course of a very different type. So here we obtain indeed an integer value, which is 1, 2, 3, 4, 5. We might also convert into the other direction, so taking an integer value and convert it into a string gives us a string. And we might also try to obtain a character from a string at a particular position, like in our last example, we take the string ABCDEF and ask for the character at position 1, which is of course B, since A would be at position number 0, and we find at position number 1 the character B.
Again, you can find complete information about the basic data types seen in the sequence in the OCaml manual. You have the description of floating point arithmetic and the module pervasives, and you have dedicated modules in the standard library about characters and strings.